A burst of radio energy brighter than an entire galaxy, vanishing in less than a millisecond. That's the shocking reality scientists faced in 2007, when the first fast radio burst flashed across the sky. These impossible signals, called FRBs, delivered days' worth of solar power in the blink of an eye, from random spots scattered across the universe. At first, experts assumed nature could explain them, but as thousands more have struck, each more confounding than the last, that confidence has turned to fear. What if some of these bursts aren't natural at all? If you think the energy is the strangest part, you need to hear what they've uncovered next. Duncan Lorimer had spent years sifting through cosmic noise, searching for the faint, regular pulses of neutron stars. In 2007, while reviewing old data from the Parkes radio telescope with graduate student David Narkovic, something impossible appeared. A single, razor-sharp burst of radio energy, lasting less than 5 milliseconds. The data showed a spike so intense, it seemed to outshine an entire galaxy, but only for the blink of an eye. Lorimer and Narkovic stared at the numbers in disbelief. No known astrophysical process could explain such a brief, powerful flash. The first instinct was to doubt the equipment. Parkes had a history of picking up interference from Earth, microwave ovens, even lightning storms. But this signal was different. Its characteristics matched nothing local. The burst's unique dispersion, a fingerprint left by its journey through cosmic plasma, pointed to a source billions of light years away. If the calculations held, the energy released in that single moment rivaled what the sun emits over several decades. The discovery sent shockwaves through the radio astronomy community. Some colleagues dismissed the result as a glitch or a fluke. Others quietly wondered if they were witnessing a new class of cosmic event. Lorimer's reputation transformed overnight, from a specialist in neutron stars to the reluctant face of a mystery that science couldn't yet explain. For Narkovic, a doctoral student, the find meant instant notoriety and a place in astrophysical history. The strange, nameless burst would soon be known everywhere as the Lorimer burst. The search for an explanation had only just begun. A single fast radio burst can unleash more energy in a millisecond than the sun produces in years. This isn't a poetic exaggeration. It's a measured fact. The radio telescopes that first caught these signals weren't designed to find cosmic explosions on this scale. The detectors register a spike at around 1400 megahertz, a frequency band familiar from satellite communications, but the power behind it is anything but ordinary. The signal doesn't linger. It arrives, peaks, and vanishes in less than the time it takes for a camera flash. Yet the energy released is so immense that for that brief instant, the burst outshines every star in its host galaxy combined. What's more, these bursts don't come from the Milky Way. They arrive from every direction, scattered across the sky, with no preference for our galactic plane. This isotropic pattern is a crucial clue. It means the sources are not clustered in any one place, but are likely scattered throughout the universe. The only way to explain the observed delay in different frequencies, a phenomenon called dispersion, is to place the origin billions of light years away. The further a burst travels through cosmic plasma, the more its lower frequencies are slowed, stretching the pulse in a way that acts like a cosmic ruler. Every fast radio burst measured so far carries this signature, confirming their extragalactic nature. The paradox deepens when scientists try to fit these facts into existing models. Known astrophysical events, supernovae, magnetar flares, neutron star collisions, can't easily account for the sheer power, the brevity, and the all-sky distribution of fast radio bursts. No laboratory on Earth and no simulation has managed to replicate even a fraction of the energy involved. The more telescopes search, the more the mystery grows. Some fast radio bursts fire once and vanish forever. Others, like FRB 180814, J0422 plus 73, keep coming back, sometimes dozens of times in a single week. The CHYME radio array in Canada has cataloged hundreds of these repeaters, each one flashing unpredictably, but from the same patch of sky. In 2019, CHIME caught FRB 180814, repeating 6 times over just a few days, with each burst separated by hours or minutes, not years. The cadence isn't regular, but the pattern is unmistakable. Something out there is recharging and firing again and again. This behavior runs counter to what astronomers expect from catastrophic events. A collision between neutron stars, for example, should be a one-time thing, violent, final, and never repeated from the same location. Yet the sky is full of both types: single-shot bursts that never return, and repeaters that seem to defy the rules of cosmic destruction. Bing Zhang, a leading theorist, points out that no single model, magnetar flares, mergers, or plasma shocks can account for both extremes. The data from CHYME and other telescopes keep piling up, but the contradiction remains. If the same physical process is behind every FRB, it's unlike anything seen in astrophysics so far. Magnetars were the early favorites. These are neutron stars with magnetic fields so intense that atoms themselves would be torn apart. The theory held up for a while. Magnetars can unleash tremendous energy in short, violent flares. But the brightest fast radio bursts go far beyond what even a young magnetar can deliver. Some bursts show nearly perfect linear polarization, with swings that defy what's expected from a chaotic magnetized surface. Others reveal energy outputs that strain the upper limits of what a neutron star's magnetic field can produce, unless the environment is tuned just so. Alternative models multiply. Some propose that bursts come from collisions between dense objects, neutron stars or black holes. But those events are rare, and the sky is crowded with fast radio bursts. Plasma theories try to solve the puzzle with exotic physics, shocks, maser emission, even interactions with dark matter or cosmic strings. Yet every model hits a wall. Either the physical conditions required are so extreme they border on impossible, or the theory can't explain both the repeaters and the one-off bursts. Bing Zhang, who has spent years defending natural origins, now admits that the latest data are pushing the limits of what any known process can explain. Each new burst seems to rewrite the rulebook, leaving even the most seasoned theorists unsure where to look next. A growing number of scientists are now asking if some fast radio bursts could be more than just cosmic accidents. Avi Loeb, a Harvard astrophysicist known for challenging orthodoxy, points to a handful of properties that keep the artificial signal theory alive. The 2025 record breaker, cataloged as FRB20250316A, is a prime example. It was localized to a galaxy's outskirts with a precision of 68 milliseconds, about the width of a dime seen from 2,000 kilometers away. Despite deep follow-up with the James Webb Space Telescope, no obvious afterglow or supernova remnant turned up. The burst didn't repeat, didn't leave a trace, and its radio spectrum was clean, broadband, but with subtle microstructure that defies easy classification. SETI protocols still flag every new FRB for signs of intentionality, narrowband spectra, encoded modulation, or clockwork timing. But so far, none of these hallmarks have surfaced. Most FRBs are broadband explosions, not the tight, persistent signals that would betray a beacon or interstellar message. Still, Loeb and a vocal minority argue that the sheer power and unpredictability leave room for engineered phenomena, alien radar, propulsion systems, or signals meant to be noticed across the universe. FRBs remain on SETI's watch list, not because they fit the mold of a message, but because their existence keeps rewriting what is possible. For some, the unsettling part isn't what we've found, but what we still can't rule out. In the search for cosmic signals, a single question shadows every discovery. What if we're not alone? And what if being noticed is dangerous? The dark forest theory, borrowed from science fiction but whispered about in real-world policy circles, suggests that any civilization broadcasting its presence could be inviting disaster. In this view, the universe is silent because every species hides, fearing that any signal might bring annihilation from a more advanced power. For decades, scientists have treated this as a philosophical puzzle. But as FRBs multiply, thousands striking Earth each year, each one a cosmic flare, some researchers worry that we may already be seen. Leaked drafts from international science panels mention galactic incident response protocols, echoing the language of emergency planning. There are no military plans, no defense measures, just a growing awareness that the next burst could force humanity to confront its vulnerability on a cosmic scale. In this silence, even a whisper can feel like a threat. The universe, once thought indifferent, now seems fraught with risk. Every unexplained signal a possible test of our place in the dark. In 2007, a single fast radio burst, the Lorimer burst, released more energy in a millisecond than our sun emits in days. Since then, thousands of fast radio bursts have been recorded, with the brightest ever, FRB 2025-03-16A, pinpointed by CHIME and JWST in 2025. Yet, despite advanced telescopes and peer-reviewed studies, the origins of many fast radio bursts remain unexplained. Current models, including magnetars and cosmic collisions, cannot fully account for their power, repetition patterns, or polarization anomalies. Some bursts even share features with artificial signals, placing them on SETI's list of interest and prompting draft response protocols. Most scientists agree fast radio bursts are probably natural, but critical gaps persist. As of today, no confirmed explanation fits all the data. These facts leave us with a stark reality. Fast radio bursts are not just cosmic curiosities, but persistent reminders that the universe still holds mysteries beyond our current understanding.